Page 34, number 166. The density of a rectangular prison shipping container must stay consistent with the guidelines of 6 kilograms per cubic centimeter. If the shipping container is 432 kilograms, what are possible dimensions for the shipping container? So let's focus in on the ask of the question. What are possible dimensions for a shipping container? Let's go back to talk more about what's happening here. So they're telling us that we have density for a rectangular prism shipping container. I'm going to go ahead and draw a rectangular prism. So here's my rectangular prism shipping container. They're asking me to figure out possible dimensions for this container. Dimensions are the length, width, and height. Information that they're telling me is density of 6 kilograms per cubic centimeter. So they're telling me density, 6 kilograms per centimeter cubed. They're also telling me that the shipping container is 432 kilograms. That's a measurement of mass, 432 kilograms. The question, though, is, well, what could the length, width, and height be? Density and mass have nothing to do with length, width, and height. You never use length, width, and height to find density. You never use length, width, and height to find mass. What do you use length, width, and height to find? And the answer is volume. Length, width, and height, if you multiply them together, give you volume. So my question right now is, well, what is the volume of the shipping container? And if I know the volume, then I can start coming up with length, width, and height. Now, since it's a density question, think about your density triangle, DMV. Since I'm looking for the volume, I'm going to go ahead and cross out V. And notice that mass over density is going to give me the volume. So I'm going to do 432 divided by 6 and see what I get. So in my calculator, 432 divided by 6 equals, I get 72 centimeters cubed for my volume. Now I can have many possible answers here for possible dimensions. As long as they all multiply to be 72, I'm good. So let me think of something. Let me think of 2. Let's say 2 is maybe the length. It's one of the 3 dimensions. Let's say it's the length. 72 divided by 2 leaves me with 36 for the other 2 numbers to multiply to equal. Now I can say 6 and 6. I can say maybe 18 and 2. I can say, what if I divide it by 3? Let's see what we get. Ooh, 3 and 12. All right, so let me use that, 3 and 12. So notice I have 2, 3, and 12 as length, width, and height. If I multiply all those together, 2 times 3 times 12, I should get 72. That works. Now this is just one set of possible dimensions. I could have, for example, 2 times 36 times 1. Those 3 should also give me 72. Let me check. 2 times 36 times 1. Ooh, 1.0 is fine. 72, yeah. So that works. If I think about something else, let me say maybe 72 divided by, let's see, will 4 work? Okay, so I have 4, I have 9, and 2. 4 times 9 times 2 is going to give me 72. So literally any 3 numbers that give me 72, the volume, then I can say that yes, those are possible dimensions. Okay, so the goal is to get the volume of 72 here, which we first had to figure out before we could do anything else. Okay, let's move on. Number 167. Find the height of a square pyramid with a volume of 90 cubic inches if the base of the pyramid has a side length of 6 inches. Okay, let's zero in on the ask of the question. Find the height for this pyramid. Let's take a look at what type of pyramid we have. Draw it and think about what we're going to do to get the height. So it says find the height of a square pyramid. Okay, so I'm going to go ahead. I'm going to draw. My base is a square. Put a point at the top, connect it to each one of the vertices. Okay, so here's my square pyramid. I'm going to show it's a square by putting a tick mark on each one of the sides at the bottom there. They're telling me the volume is 90 cubic inches. So I'm going to write down V equals 90 inches cubed. Now you should think to yourself, that's strange. They gave me volume, and yet they want me to find the height. Usually, I would use the height in order to find the volume. But now we're looking at it in reverse. We have the volume and we have to get the height. Okay, so this is probably going to be a working backwards problem. But let's keep reading. If the base of the pyramid has a side length of 6 inches. Okay, so let's put that in. 6 inches for the length here, 6 inches for the width. Everything is 6 inches for your base. What you want to get is the height, h. That's missing. Okay, let's think about how we got the 90 inches cubed. Let's think about how they came up with that volume. Well, the generic volume formula for anything with a big point is 1/3 big BH. Big B stands for area of your base. So I'm going to replace big B with the area formula for this type of base, which is a square. So since it's a square, I could say length times width. I can say side length times itself. I'm just going to use length times width. And then bring down h for height. So that's how they came up with 90. They did 1/3 times the length times the width times the height. Now let's take a look at what variables I can start filling in here. I have the volume, that's the 90. I have the length, that's a 6 inch. I have the width, that's also 6 inches. What I don't have is the height, and that's my only remaining variable. So I'm going to be able to plug in and work backwards to get h. If we start plugging in, the volume is 90 equals 1/3. Length and width are both 6, and h is my variable. Let's start simplifying a little bit. 90 equals 1/3. 6 times 6 is 36. H. I hate seeing the 1/3. I always do the same thing to get rid of the 1/3. I multiply both sides by 3. And that will cancel out my 1/3. 90 times 3 is 270. Leave me with 36h on the right. Last step, if I divide both sides by 36, I'm going to be left with just h, which is what I want. I want the height. So in the calculator, 270 divided by 36 equals 7.5. So my height is exactly 7.5. Perfect. 7.5 inches. So the key for this problem is noticing that if they're asking you for a measurement, like a length or a height, and they give you volume, or maybe they give you area, or they give you surface area, but if they give you something that would have required a formula to solve for it, you want to write that formula down, plug in what you know, and work backwards to get the variable that you're looking for. In this case, it was h. Okay, let's go on to the next question. Number 168. Find the area of the base in the cone picture to the nearest hundredth. Okay, so our ask, find the area of the base. Now, what's the base of this cone? The base is a circle. So what are they asking you to do? They're just asking you to find the area of the circle. This is not a volume question. This is not a surface area question. This is a plain old find the area of a circle. So your goal right now is to do area formula of a circle, which is pi r squared. Now, the only thing that you need is the radius, and then you'll have the area of the circle. Now, take a look at your diagram. The radius is missing, but what you should notice is we have a little right triangle in here. We're going to be able to solve for that radius by using that right triangle. We're not going to use trig because we don't have an angle. Instead, we're going to use Pythagorean theorem. Let's solve for r using Pythagorean theorem, and then plug that r in to our area formula for a circle, and then we'll have our answer. So, remember your Pythagorean theorem is a squared plus b squared equals c squared. C is always your hypotenuse. In this case, that's the 13. It's the one across from the right angle. So we're going to plug in 10 and r as your a and your b. So 10 squared plus r squared equals 13 squared. Let's start expanding. 10 squared is 100 plus r squared equals 13 squared, which is 169. Subtract 100 from both sides. Now we have r squared equals 69. To get r by itself, we're going to square root both sides. The square and the square root cancel. So now you have r equals the square root of 69. Let's see if that gives us a nice number. 69 square rooted. No, definitely not a nice number. So I'm just going to keep it like that, square root of 69. And then we're going to plug it into the area formula. So now plugging it in, area of a circle equals pi. Your radius is the square root of 69 squared. Now if we start expanding, I'm going to bring down the pi. And now you'll notice the square root and the square are going to cancel out. So now we just have 69 times the pi. If they wanted the exact answer, it's 69 pi. But they wanted to the nearest hundredth. So let's go ahead and multiply in that pi. So 69 times pi equals 216 point. They want to the nearest hundredth. So 216.77. So area of the circle is 216.77. And this is going to be in terms of inches squared because it's area. So you may have thought because it's a three-dimensional object, you were going to have to find either volume or surface area, but that's not what the question is asking. All it wanted was the area of the base. So you really need to pay attention. What are they asking me? Do they want volume? Do they want surface area? What is the ask of the question? Okay, let's keep moving. 169. Icing is being put around the bottom layer of a wedding cake. Find how much area the icing must cover to the nearest tenth. Okay, icing is being put around the bottom of the cake. Find how much area, so we're talking area, that the icing must cover. Now, if they said around the bottom of the cake, that means they're not putting it at the top or on the bottom. They're just putting it where the blue section is. That blue section that goes around the bottom of the cake is known as the lateral area. So they're asking you for lateral area of the bottom of the cake. The bottom of the cake is a cylinder. So what you're doing is you're finding the lateral area of a cylinder. Now, the formula for lateral area of a cylinder is 2 pi r h. So your circumference times h. Now let's take a look. Do we have the r and do we have the h? We definitely have the h. That's the 14.7. And the radius, well, it looks like they gave us the diameter. So your radius would actually be 10 inches here. Yes, since we have the radius and we have the height, we're ready to plug in. This is a pretty straightforward question. So plugging this in, now we have 2 times pi times your radius of 10 times the height of 14.7. We're going to multiply all of this together and round our final answer to the nearest tenth. So in the calculator, 2 times pi times 10 times 14.7 equals 923.6 square inches. 923.6 inches squared of icing. Okay, this was a pretty straightforward question as long as you knew the lateral area formula, which is 2 pi RH, and you understood that it's lateral area if they just want to go around the cake and not put any icing on the top or the bottom. That would be surface area. But in this case, it's just around the cake, which is lateral area. Okay, let's go on to the last question on this page. 170. Write the equation of a line that is parallel to 2x equals 1 minus 3y and passes through the point 9, 4. Okay, so notice that it says write the equation of the line. This is a money pays bills question. We're looking to use y equals mx plus b with m a point and solving for b as our game plan. Now the key word in this is that it's parallel to this equation. 2x equals 1 minus 3y. So you're looking to do an equation of a line parallel. So that's going to tell you that your slope should be the same as the slope of the line given. Now I'm going to go ahead and I'm going to rewrite that equation. 2x equals 1 minus 3y. Most of you like to see the y value on the left. So what we can do first is we can take that negative 3y and move it to the left. How would we do that? Well, we would add 3y to both sides. It's going to cancel on the right. On the left, we're going to have 3y plus 2x equals 1. Then let's get rid of the 2x. So we're going to subtract 2x from both sides. So now we have 3y equals negative 2x plus 1. Your last step is going to be to divide every term by 3. So now we're going to have y equals negative 2 over 3 x plus 1 over 3. Now the reason we care about this line is because we want to look at the slope, the negative 2/3. If your line is parallel to this line pictured, or rather the line given by the equation, you should have the same slope for your line. So we're going to put in that our slope is also going to be negative 2 over 3. If they said perpendicular, our slope would be a positive 3 over 2, but they want parallel. Now your line should also pass through the point 9, 4. So I'm going to put in 9, 4 in our graphic organizer for the point. Once you have the slope and the point, you can plug in and solve for your b value. So let's plug in 4 equals slope of negative 2 over 3 times 9 plus b. Let's go ahead and simplify. 4 equals, so this is a no calculator, so we're going to work this out. Negative 2 over 3 times 9. Put the 9 over 1 and multiply across. Negative 2 times 9 is negative 18. 3 times 1 is 3. Negative 18 divided by 3 is going to be a negative 6. So I'm going to put negative 6 plus b. Next, we're going to go ahead and add 6 to both sides to get the b by itself. 4 plus 6 is 10, and that's your b value. Once your entire graphic organizer is filled in, you are ready to state the final answer. Y equals negative 2 over 3 x plus 10. Okay, and we're done with the question. The only tricky part of this was converting your original equation into y equals, because the y value was not on the left like most of us are used to seeing it. But the rest of it, pretty simple. Okay, you only have one more page. You can do this. Let's go on to the last page.